Yes, hello. Good morning, guys. My name is Patrick Kamala. I am a tutor and educator for mathematics and physical sciences, grades 10 to 12. Welcome once again to our chemical change part 3. We are proceeding with the quantitative aspects of chemical change, and today we're looking at the molar volume. Now, this molar volume is to do with gases. Okay, it's to do with gases. Now, we have some important information before we proceed. Number one, at STP, that is to say, standard temperature and pressure, 1 mole of any gas has a volume of 22,4 decimeters cubed. Please don't forget that. We are saying 1 mole of any gas has a volume of what? Of 22,4 decimeters cubed. We are going to be using that in our calculations shortly, so please don't forget that. Now, STP means standard temperature, is that which is 0 degrees Celsius, or you can call it 273 Kelvin, and then standard pressure, which is 101,3 kilopascals, and which is also equal to 1 atmospheric pressure. Okay. For example, 1 mole of oxygen gas has a molar mass of 32 grams per mole and a volume of 22,4 decimeters cubed at STP. Let me say it again. 1 mole of oxygen gas has a molar mass of 32 grams per mole and a volume of what? Of 22,4 decimeters cubed at STP. Let us proceed. Maybe it's gonna make sense to you as we continue. Then 28 grams per mole. Beg your pardon. Yes, beg your pardon here. And then 1 mole of hydrogen gas has a molar mass of 2 grams per mole. What about the volume? It is 22,4 decimeters cubed at STP. Remember that everything is at STP here. And then 1 mole of nitrogen gas has a molar mass of 28 grams per mole and a volume of what? Of 22,4 decimeters cubed. Now note that every molar mass of a gas here, as long as we say at STP, it has a volume of what? A volume of 22,4 decimeters cubed. Even here, a volume of what? 22,4 decimeters cubed, and oxygen, like we saw already. Now, in here, so we see that all the gases at STP, their molar masses have what? 22,4 decimeters cubed. Okay, now you're going to see that in calculations. Don't worry about that so much for now. So, in conclusion, we can note the following, which says that equal volumes of all gases under the same conditions, that is to say the same temperature and pressure, contain the same number of particles. Contain what? The same number of particles. So the volume of the gases that react all are produced in a chemical reaction are they are proportional to the number of moles. For example, if I have nitrogen gas plus 3 hydrogen gas to give me ammonia, if you check here, what is my molar ratio? Now my molar ratio is this one here. You see here I have 1 mole of nitrogen gas, that is 1 of nitrogen gas, plus 3 moles of hydrogen gas to give me 2 moles of ammonia. Okay, that's why I say here that 1 mole plus then 3 moles, then to give us 2 moles. So here now, because all these are gases, now please understand that moles are proportional to the volumes. So likewise, 1 volume of nitrogen gas reacts with 3 volumes of hydrogen gas to produce 2 volumes of ammonia. So if I consider STP condition, that is standard temperature and pressure, I'm going to find out that because this is 1 mole, it means that if I have 22,4 decimeters cubed of nitrogen gas, I am going to react them with 3 times 22,4, which is what? Which is 67,2 decimeters cubed. I repeat, if I check, let's check it out on our calculator, 22,4 decimeters cubed. Now if I come here and I have the 22,4 decimeters cubed. What is my calculator now? Okay. Now here we have our calculator. Here is our calculator. Okay, so we said let's get something here. Now, like I said, that if we have the 22,4 decimeters cubed, okay, for the nitrogen, 22,4, then multiplied by 3, okay, to get how much reacts there. So if I press ST here, you see it is 67,2. So because I'm dealing with STP conditions, it means that the 1 mole of nitrogen gas, which has got the 22,4 decimeters cubed, must react with the 67,2 decimeters cubed of what? Of hydrogen, and I'm going to produce 44,80 decimeters cubed of ammonia. I hope we are together. Now I'm getting this by using ratios, as in proportions. 1 mole 22,4, 3 moles 67,2, and then 2 moles, that is 44,8 decimeters cubed. Let us proceed. Now we can find the proportions using algebra. For example, if I have A moles of gas A plus B moles of gas B reacting to give me C moles of gas C and D moles of gas D, where A, B, C and D are the moles, then if I use my ratios, now as you can see here, this A to B is equals to C to D, like this. A to B equals to C to D. So it means I can manipulate it, and using mathematics I can say that A multiplied by B equals to B multiplied by C. Also I can also have it as A divided by B equals to what? Equals to C divided by B, as we're going to see in examples shortly to come. Okay. Let us look at examples here. The question says, find the volume of oxygen gas that will react completely with 500 cubic centimeters of sulfur dioxide at STP in the equation below. So here I have the volume of sulfur dioxide, which is 500 cubic centimeters at STP, and I need to know how much oxygen is going to react with that completely. Let me explain again. The question says find the volume of oxygen gas altogether that will react completely with 500 cubic centimeters of sulfur dioxide gas at STP in the reaction below. Now if you look at what I have here, all these are gases, right? And we said yesterday that we did with decimeters cubed. With what? Decimeters cubed. So tell me now, somebody, if I have 500 cubic centimeters and I want to get decimeters cubed, what must I do? We said you divide by what? By 1,000. So if you divide this, you're going to get 0.5. So in other words, I have 0.5 decimeters cubed of what? Of sulfur dioxide. I have what? 0.5 of what? Of sulfur dioxide, that is decimeters cubed. Okay, 0.5. And I want to see how many decimeters cubed I'm going to need for oxygen to react this one here. Let's check our solution here. Okay, now as you can see, that's my volume decimeters cubed. Now the mole ratio here is 2:1. In other words, 2 moles of sulfur dioxide react with 1 mole altogether. So, and what about the 0.5? What about what? 0.5 of sulfur dioxide is going to react with how much? That's why I'm using X here. Now to get my X here, it's very simple. What I do, I simply cross multiply. I do what? I cross multiply like this. I'm going to use okay, I beg your pardon here. I beg your pardon here. Now I use these ratios, but I'm using 2:1. So I multiply the 2 with this X, and then the 0.5 with 1. That's how I cross multiply here. Let me put it here like this 2. The 2 corresponds to sulfur dioxide, and then the 1 corresponds to what? To oxygen. What about here? 0.5 corresponds to sulfur dioxide. Now I want to know the one for what? For oxygen. So I cross multiply here like this. This 2, I multiply it by X. When I'm done, I equate it to 0.5 multiplied by 1. Okay. That is what is 2 times X, that is 2X. So 2X equals to 0.5 times 1. So what do you get here? Let's check. Now when I check what I have here, I see that to get my volume for oxygen, after cross multiplying here, I do what? I simply divide by 2 both sides, which gives me 0.25 decimeters cubed of oxygen gas. Okay, I hope we are together. Don't forget what we did. After cross multiplying, we got this equation here. We got it as 2 times X equals to 0.5 times 1, and then we divide by what? Divide by 2 to give us 0.25 decimeters cubed. I hope we are together. So here we have more vector examples on molar volume. The question says study the balanced equation below, that is still nitrogen gas plus hydrogen to give us ammonia. They say convert 250 cubic centimeters to the correct acid for volume. Now we say that it must be decimeters cubed, so you divide by what? By 1,000. What do you get? 0.25. Okay, let us proceed. Now they say that if 22.4 decimeters cubed of nitrogen reacts completely with the hydrogen, calculate the volume of ammonia that forms. So they're saying that if 22.4 decimeters cubed of nitrogen reacts with what? With the hydrogen. Calculate the volume of ammonia that forms. Now here what is important is to know what are we dealing with. So we have the 22,4 for nitrogen, and we want the volume that forms. And we want what? The volume that forms. So what do we do? What do we do here? Okay. Now if we check what happens here, we see that remember that this is the equation here, which we have, that is nitrogen plus 3 hydrogen to give us ammonia. Now I'm dealing with nitrogen, which in mole ratio is 1 to 2, that is nitrogen with ammonia. So for now, this one is not required. So I'm dealing with now the 22,4, and I want to see x. X is the volume which has been formed by ammonia for ammonia. So this time I'm going to cross multiply. But not here. What do I cross multiply? I cross multiply this one times this x here equals to 22,4 multiplied by what? By 2. Okay, now I'm dealing with distance which are in the red. This one is for nitrogen. I formed the 2, yeah. Then x is the volume formed for ammonia. Then here the 22,4 is the available nitrogen, but here the mole ratio is what? It is 2. So after cross multiplying, what happens? What is 1 times x? That is x, and then 2 times 22,4, it gives me 44,8. So that will be the volume formed from ammonia. Okay, let us continue. Now the other part of the question said what? It says that, that's question 3. Okay, now they say calculate the volume of the nitrogen that will react completely with the 33,6 decimeters cubed of hydrogen. So this time I'm dealing with what? Nitrogen and hydrogen. Okay, so I want to see which volume of nitrogen that is going to react with what? With 33,6 decimeters cubed of hydrogen. Let's check it out. Now this time what I have is that I'm dealing with nitrogen and hydrogen. Now this part is not required here, so this time 1 is to 3. By the way, before we use our cross multiplying method, we must balance the equation. Okay, so if I cross multiply here, how do I do it? I'm going to say that this 1 multiplies the 33,6 equals to x multiplied by 3. So what is 3 times x? That is 3x equals to 1 times 33,6, whereby to get my x, I do what? I just divide this one by what? By 3, which gives me 11,2 decimeters cubed of what? Of nitrogen. That's what is required to react completely with the 33,6 decimeters cubed of what? Of hydrogen. So that's how we do this. I hope we are together. And please try this class activity. Try this class activity here. Okay, it continues. Okay, hope you see it. And then let us proceed. Alright, once again, now whatever we have done so far, we can do with the mixed stoichiometry calculations and see how we can solve for with more calculations. Let us proceed. Now in here we are going to use all the formula which we have seen. So here we have a little example. They say calculate the mass of potassium nitrate which can be obtained when 7 grams of potassium hydroxide are neutralized completely by an excess of nitric acid according to the balanced equation below. So the equation is potassium hydroxide reacting with nitric acid to give us what? Potassium nitrate plus water. What does the question say? They said that calculate the question says that they say that calculate the mass of potassium nitrate which can be obtained when 7 grams of potassium hydroxide are neutralized. So I have 7 grams of what? Of potassium hydroxide. And I want the mass of potassium nitrate. Don't forget that. I want to get the mass of potassium nitrate. The mass of what? I want the mass of potassium nitrate when 7 grams of potassium hydroxide are neutralized. Okay. Let's see how to do this now. Okay. Now what happens here is that I use a table to summarize everything here, and this is how I do it. This is how I do it. This is how I do it. Now, if you check again here, you see that I have to use a balanced equation here. So potassium hydroxide aqueous plus nitric acid aqueous, it gives me potassium nitrate aqueous plus water liquid. Now the molar masses using my periodic table, I can get it for potassium hydroxide as what? As 56 grams per mole. And then this side, because I'm dealing with potassium hydroxide and the nitric acid, also have to find the molar mass for what? For potassium nitrate, which is 39 plus 14 plus open brackets 16 times 3, which gives me 101 grams per mole. Now, because it's balanced, the mole ratio is 1 to 1 to 1 to 1. Okay, now the question says that I have 7 grams. I have 7 grams of the potassium hydroxide, and I need to know how many grams am I going to get for this other words for nitric acid. Okay, now what I do here, again I'm going to use my cross multiplying. If you see here, the 7 grams is this one here, try to get, and then I want to get my x here. So now check this out. I'm going to cross multiply. You see this 56 grams per mole is going to be multiplied with this x here. When I'm done, I'm going to equate the 7 multiplied by 101. It is still about cross multiplying as well. Okay, and I do everything in this same table here. That's why I have x times 56 equals to 7 times 101. So if I divide by 56, I get what? I get 12.63 grams. Okay, I hope we are together. If you are not, please, you can inbox me, or you can come to class, or you can come at our tuition center at Rosetta College. I will explain more. Okay, let's take example 2. A sample of limestone, that is calcium carbonate, with a mass of 250 grams is treated with excess hydrochloric acid. With excess what? Hydrochloric acid. And then let me read it again. I'm saying that a sample of limestone, that is calcium carbonate, with a mass of 250 grams is treated with excess hydrochloric acid. And so what happens next? They say that okay, the balanced reaction that occurs here. So we have calcium carbonate solid plus 2HCl aqueous to give us calcium chloride plus carbon dioxide gas plus water. So the question says that calculate the number of moles of hydrochloric acid that is required to react with what? With 250 grams of limestone. Calculate the number of moles of hydrochloric acid that is what? That is required to react with 250 grams of limestone. And then calculate the volume of carbon dioxide that will be produced when 250 grams of limestone reacts completely. And what else does it end there? Let's check. Okay, yeah. Now this is a worked example which we do in class when we come for our extra classes or at school. Okay, now after that worked example, here comes a class activity that is about stoichiometry, that is 011. So these are the questions here. Please try them out, and in case you don't get it, please inbox me, or you can come to school at Nulderland, or you can come for extra classes at Tech College in town on 92 Skuman. Okay, I hope we are together. If you have got your handout, please